So, we are recording. Be careful what you sneeze. Right, so I just want to check, can you add and subtract decimals to start with?
Yes.
What we're doing is following on from our place value stuff. It's very important that we remember about place value. Which is why at the time I said to you, let's avoid moving decimal points. The decimal point does not move when we multiply decimals by 10. We change the value of the number. So if we multiply it by 10, we move it up. Okay? I will use your names on video and tell you off. Okay? So, I'm going to take the questions from your homework. Right? So if you did them, then you'll be like, oh great, I know I got them right. So if we're going to do a question like 59.23, add 57.69. Okay. Does everyone know how to do that?
Yeah.
Yeah?
Yeah.
So what would a method be to make sure we get it right? If you were going to explain that to a younger student who hasn't done it before, what would you tell them to do?
When you're adding a decimal, always make sure the decimals are lined up.
Okay, so we're going to use column method. I didn't change that colour, it just did it anyway. So we're going to use a column method and we're going to line it up. So 59.23. And this is why the decimal place does not move ever, because we have to keep it lined up because of the value of the numbers. The decimal point specifies that that's the difference between the units and the tenths. Now, when we add numbers together, we try and add them to numbers of the same value. So, for instance, we know that the 9 and the 3 are in the same value column. Right? So if we're going to do our column method, we do 3 add 9 makes
12, 11,
12. So I don't know how you would do this, maybe it's different to me, but I would go 9 add 3 makes 12, so I would put a 2 and then I carry the 1 down the bottom. Now wherever you put it, you can carry on doing the same thing. Absolutely fine. So then I would do 6 add 2 is 8, plus 1 is 9. Now I need to make sure that my decimal point stays there. And 9 add 7 is 16, so I'm going to carry the 1. 5 add 5 is 10, plus 1 is 11. So we've got 116.9. Okay, no problems. What's, just out of interest, if I give you a different one to do, is that alright?
Yeah.
So if I said to you 1.005402, add 30, no, sorry, don't write that down. It's going to rub out in a minute. Add 1.1003. Okay. So I just ask which number, the A number or the B number, is the bigger number? Which one's larger in value? How do you?
A?
A's larger.
No, B. Sorry.
Give a reason.
Because after the 1 in A, there's just no value because the 0 has no value.
Yeah.
But in B, after 1, there is a value of 1.
Yeah.
And then there are no values, and then there's...
Yeah, spot on. So, why is the common mistake to say A is the bigger number? Yeah. Because there's more digits. Okay. So quite often people would say A is the bigger number, but I'm glad. Does everyone see that?
That's what I was thinking. Yeah, because it's 0, 0, 9, 5.
Yeah. So we see it better if we do again our column method. If we're going to add them together, so they're 1.0054 0.02, add 1.1003. If we look at it like that, then we can clearly see that the 1.1, if I stop there, so if I was to do like I was rounding, do you remember doing the rounding? If I was to do that, then this number is obviously bigger than that one. So it doesn't matter what comes later, because these numbers are less valuable, aren't they? Okay, so we can see that that one's bigger. What do I do to add these?
You add zeros.
Just bring, yeah, we can add zeros. That enables me to add them. So what do we get? 2 add 0, 2, 0,
7.
okay.
Yay.
If I now set, just checking from before, round your answer to 3 significant figures. So if I ask you to do that, so it can quite often happen. So say, here's a calculation, give me the complete answer. But if I said now round your answer to 3 significant figures. It's going to be in your test, but it needs to be in your head.
I know what to do.
You know?
Can I use board?
Well, can I just ask, does anyone else know? Archie knows, I know. You've got your hand up, you're going to explain, but does anyone else know?
What to do?
So does anyone else not know?
I think I know.
You think you don't?
No.
Okay. Cameron?
Oh wait, yes I know.
Wait, I'm trying to figure it out.
You're trying to figure it out.
Wait, I know.
So bear in mind that, actually, make sure when you explain, you have to explain to people that
Okay.
don't know.
Can I come up?
Yeah.
Okay. Okay, so does this work?
I think it should work, yeah.
Okay, so this is one significant figure. That's 1. This is 2, and then this would be your third significant figure. So then you'd circle this, and because 5 makes it go up the vine, I'm just going to do that. It would be, you change this to a 1, and then you would keep those 3, so 2.11, and then you wouldn't have to add zeros because it's behind
the
a decimal point.
Yeah.
Oh,
You get it? Cool. Do you remember, I think the only difference I did was say, well, if I've got, I put a line there, didn't I?
Oh yeah.
And just said, the rest of it we kind of forget about.
wait, I thought significant figures said after this.
Significant figures can be anywhere.
Oh.
Significant are the most valuable.
So
Decimal
if
places.
it's like
Exactly.
0.0 something, it starts with the numbers.
Exactly.
0.005 starts with
A
5.
lot of people think significant figures, they relate to money. It's like how much money you have. And it makes more sense because the most significant, hope you're not writing on anyone, can you? No? If you think about money, wherever it is up the number scale, the number furthest to the left is the most money, so that's what we do. Okay. What about then having this question? So 26.09 add minus 12.7.
I know. I think.
Okay. Does anyone else know or think they know? I want to try. Abby, what about you? You're quiet.
I think I might know.
Abby? You got any ideas of what we could do?
Ew.
Ew, that was gross.
Just add it and then add a minus at the end.
Add them and add a minus to the end. So you would just do 26.09 and add 12.7, and you would do, so let's just say if I went through this process like that, then you would do a minus. Yeah? Is that where you would go? So, all right. Does anyone agree with that? You agree with that? Yeah. Several people agree. Actually doesn't. Okay. Abby doesn't.
I
Okay.
don't. Okay, so basically the reason why I don't agree is because there's a plus and a minus, and a plus and a minus equals a minus. So instead of 26.09 plus negative 12.7, it would be 26.09 take away 12.7.
Did you all forget you're adding and subtracting negative numbers?
I got it. Because I was thinking
No,
about
you didn't.
I was thinking
Yeah.
about complexity, how if you add,
exactly.
you're adding a negative.
Yeah, but that's it. But adding a negative is not the same as sticking a negative sign at the end.
No, I know. I was thinking because if you add a negative, you're adding the negative.
Okay, so if you flipped it around,
right.
minus
Right.
2.7 could go off to get.
So this is like we're at a positive situation. It's just not a positive whole number anymore. It's a positive decimal, and we're adding negatives. Now, are we enough positive to stay positive?
No.
Well, if I'm only adding 12, but I'm at 26. So you think about it, Gotham City is at a value of positive 26. I'm going to add negative people, so that would make it go in the negative direction, but I'm only adding 12.7 negatives. So will I stay positive or will I go far enough to be negative?
Stay positive.
So I'll stay positive. So actually, what is it the same as? So it's not that, is it? We can't just add them and stick a negative.
I know the answer.
So we do, if we add a negative, it's the same as
Negative.
subtracting 12.7. Okay? So now we have to do a subtraction. So this is a good check. Do you know how to subtract? Okay, Taylor, can't it? Okay?
Yay! You're actually asking.
So, okay. So 9 take away 0 is 9. Ew. And then you can't take 7 away from 0. So you gotta go up to the 6. The 6 will turn into a 5. And then the 0 will turn into a 10. And 10 take away 7 is 3. And then 6 take away 2 is 4.
That's because you're
Wait. Oh
you're
no!
not writing, you see. You're just doing it all in your head. You didn't write it out, did you?
Wait, can
No,
I?
I did. It's just.
So
okay,
for
so then
instance,
5
if
take
I
away
do, can I add it? What you did was you made that a 5,
Yeah.
and the 10
And
that
it's
you
a
moved,
10.
that becomes a 10.
And then, oh, okay. So then 5 take away 2 would be 3.
Yeah,
And then you
I
make
don't know why I changed that.
And then
This
2
one
take
happens
away
to
1 would be
Sarah,
1. So it's
So we've got, and is it a
39.
positive or negative answer? It's a
it's a positive.
It's a positive answer. Okay.
Sorry, I was bored. I wanted to do this so bad.
So can you do for me?
Wow.
So we're now mixing all our pluses and minus stuff, directed numbers, with decimals. So everything you know how to do with whole numbers is in what? Oh, I was going to tell you. What are whole numbers called? I was going to say it, but I didn't. What are whole numbers called? What are they called?
Integer?
Integer.
Integers, well done. Good.
What are integers called? Numbers.
Okay, so I'll leave you to do that one just a sec. Okay, so this one, 47 add negative 20.0000 whatever, 3. Okay, so we've already decided if we're adding a negative, that's the same as taking away. So we're actually doing this. So I've done that. So we're going to subtract. Now, several of you initially made the mistake that we're expecting. Because a lot of you went, oh, yeah, so it's 27.003.
No, we're supposed to add the zeros.
Okay, so,
No, that's what I did.
but hang on, I'm saying lots of us did, and we all kind of did it correctly at the end, but lots of people did that immediately, because you just look at the 47 take the 20. And that's what it would be. But actually you are subtracting the 0.03, aren't you? 0.003. So you can't just leave it there, because that's what you're actually subtracting. So, can't be quite as simple as that. And we said earlier that what we need to do is bring our zeros in, because we should add or subtract numbers of the same value. But this is where it gets a bit like, oof. Now, I'm going to let Cameron, because she did it first.
You're so excited.
I love writing on the smartphones.
Okay, so you would, since none of these are like whole numbers, well, this is
Yeah.
0, you would move over to this number, and then change it to a 6, and add it to here. Oh,
Yeah.
And then change that to a 9, and add the 1 over here, so it becomes a 10.
Yeah.
And then change that to a 9, and then make that a 10. And then that's 7, and then that's 9, 9, 6, 2.
26.99. Good.
Well done.
Okay. Is that right? Easy enough. That's easy enough. Okay. Now I'm gonna check something. It's slightly different from our objective, but if I said to you now 0.2 times 0.3. Okay. Is there anyone that thinks, yes, I know how to do that already? So this is not adding, subtract, this is multiply.
Yes.
You think?
Yes. Can I write what I think?
But
You
what do you think? Can you think what you write?
Okay, get up. Write what you think the answer.
Okay, so
Wait, why are you?
One at a time.
Okay, so basically,
Both.
since this is first, or this is just A, and then that's B. I'm just labeling
Yeah.
this. So then you put A first.
But does it matter which way around we do
Well, no.
multiplication? No, it doesn't, but that's fine.
3. And you could do that and then add the little decimal.
Can you all watch this and check what she's doing? Rather than kind of highlighting
Okay.
it.
So 3 times 2 is 6.
Okay.
That'd be 6. And then 3 times 0 is just 0. So that'd be there. And then you put a 0 here. And then you do 0 times 2, which is 0. And 0 times 0, which is 0. And then it would
Let
be-
me. I'm just going to move it there.
Okay.
There you go.
And then it would be 6.
Oh, hang on. Change. There you
It
go.
would be 6.00.
So 0.6. Is that what you think? Okay. Anyone else? Do you agree or disagree? You think there's anything wrong with that?
no, I don't disagree or anything, but the cheat way, I think something I would do if I wasn't paying attention would be like,
Don't admit to that. But yeah, go on.
like I do 0.6 because I would.
Well, that wouldn't be a cheat, would it? That would be knowing that you don't need another zero there.
Yeah.
Does anyone have any problems with their answer at the moment? No, do you think that's the right answer?
Yeah, but what if it ended up being?
Well, can I tell you before you say what if, can I tell you that's not the correct answer?
The decimal points are like.
Is it just 0? Actually, I don't know. Decimal points.
Yeah. Well, see, the thing is, I will debate that. The decimal point is not in the wrong place. The decimal point on the diagram is in the correct place.
I know, but it it is. It's 0,
What?
6.0.
Oh, it's 0.06.
Okay, the
Yeah.
numbers are in the wrong place.
Oh.
Why? How do we... Right, okay. What makes you say, or what's your reasoning for saying it's 0.06 instead?
Because I know the zeros.
Are you guessing? Because I just told you it's wrong, or...
Yeah, they were just guessing.
No, I was telling.
Wait, I need to think.
Okay, can I give you a method? Now this, normally what people might do is avoid explaining this to you, to try and keep it simple. But I know that you guys can deal with this, right? Because we've done work on multiplying and dividing by 10, haven't we?
Yeah.
Right. So what if I were to change these numbers, instead of writing 0.2, would you be okay if I were to write this as 2 divided by 10?
Oh, yeah.
Would you be alright with
Yeah.
that? Yeah? And I'm going to multiply it by, well, what would this be in the same way then?
3 divided by 10.
Yeah. Now, what do you know about BODMAS in terms of multiplication and division?
It's bit mass.
BITMAS, PEMDAS, BODMAS, whatever. What do you know? PEMDAS,
Pengas?
DAS.
Oh, what?
When do you do multiplication and division?
Before I did the practice.
Okay, but do you have to do multiplication and then division, or division then multiplication, or does it not
Division
matter?
then multiplication.
Sure.
Yes.
Yeah.
Bid
Big math.
mass. Yeah.
Okay.
With muss.
Yeah.
We should have it as
dividing
mass.
and the end is multiplied. And the you.
So, for instance, if I were to say to you, 2... No, sorry, I'm going to change that number. Because this is quite important, I guess. If I would say 4 times 3 divided by 2. What if I were to change that around and say 4 divided by 2, but then times by 3?
It would still
I-
equal the same answer.
Oh, well, but it's the same answer. So could the multiplication and division be done the other way around?
Yes.
Do you all agree that both of these are 6?
Yes. I agree.
Yes.
So as long as I keep the multiplication with the 3 and the divide by the 2. So what if I were to do the divide by 10 and the divide by 10, and then I've got the times by 3? What if I were to then do 2 times the 3 and then divide by 10 and divide by 10? I've just rearranged it. So I've got the...
Oh, get it?
Does it make sense?
Wait, no.
I get it.
I get it.
So here are my divide by 10s. Here's a divide by 10. Here's a divide by 10. And then I've put the times by 3 first by the 2. Is that making sense?
It would make 0.06.
Okay, so then I can do that, you see. Sorry, I'm running out of space here. Can I rub out this? You're okay with that now? Okay, let me rub out this. It's going to be on the video. So that would then equal what? So we would do 2 times 3 is 6. 6 divided by 10 and then divide by 10 again is the same as doing 6 divided by 10 twice.
20.
Good. Remember, divide by 10 moves columns. There's 2 columns. So divided by 100. So the answer would be 0.06. Okay.
Oh.
Now, some people, to do a shortcut, would then do it like this. Sorry, I will let you go. So some people would say 2 decimal places in the question, 2 decimal places in the answer. Okay? So that would be a shortcut. But we'll do a bit more of this next time. So the multiplication of
Wait, will
Yes.
this be on the test?
That may well be, yeah. We've got plenty of time.